Our focus standard for this lesson comes from Grade 7 Geometry Standard 2. Focus on constructing triangles from 3 measures of angles or sides. Our topic comes from AGR, Triangle Vocabulary and Notation. Our essential question for this lesson is, what vocabulary and notation are used to describe and identify parts of triangles? Please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. Let's go ahead and jump right in. Now we all know a triangle is a closed polygon with 3 sides, 3 vertices, and 3 angles. It is important to note that the sum of all 3 angles is exactly 180 degrees. So with this in mind, and please copy this in, we're going to look at how to identify and describe with proper vocabulary and notation these parts of a triangle. So here I've noted that we're talking about triangle ABC, and I'm drawing it here. And right now, it says we're going to identify sides and angles. Right now, it's the vertices that are labeled. Another word for those are the corners. So let's start out by talking about identifying the sides. So on this triangle ABC, I have marked here this line segment that creates one side of the triangle. Now let's talk about how we would identify this side. This side that stretches from vertex A to vertex B, which would be noted like this. The vertices A and B with a line above it. So this is side AB made by line segment AB. We want to make sure that we label all 3 of these sides. Go ahead and see if you can label the other 2 and check back and compare. That's right, our second side is this one right here that stretches from B to C, vertice, so it is labeled as side BC, or line segment BC. And our third one, stretching from vertex A to vertex C, is line segment AC. Those are our 3 sides. We've talked about the vertices, now let's talk about naming the 3 angles. I bet you can think of a way to name the 3 angles using the methods from our Name and Classify Angles video lesson. Go ahead and give that a try and let's compare. Here I've labeled our first angle for us. It's on vertex A. I've used the angle marking BAC. Notice we're using the other points to talk about this angle here, and the vertex always goes in the middle. We can also, because we're only talking about this on a closed polygon, and we're not talking about angles that would extend in other directions from the same vertex, we can also just call it angle A. So using this, if you haven't done so already, please go ahead and label our other 2 angles. That's right. Next we have angle ABC, ABC. You might have also said CBA. As long as vertex B is in the middle, or just call it angle B. Down here I have angle ACB and angle C. So now we've identified the 3 sides and the 3 angles that make up our triangle here. Let's use a little bit of vocabulary to talk about how these parts are in relation to one another. So for these sentences here, I would like you to copy them down along with this word bank. The words between, opposite of, adjacent to, and included. Let's think what we can use to fill in the blank on each of these sentences so that we can practice using this vocabulary to describe how the parts of this triangle are related to one another. So here's our first one. Angle B is blank AC. Let's take a look at what they're talking about. Angle B, so I'm going to put an angle arc here, is blank to line segment AC. Which of those words do you think would make the most sense? Is angle B between a line segment AC? Is it opposite of, adjacent to, or included? Well, it's not between. And I think included is really similar, so it wouldn't be that. Adjacent to we learned about when describing angles. Opposite of. Notice that angle B is here, and directly across from it is the line segment AC. That must mean that they are opposite of. Let's go ahead and fill that in. Next sentence. Line segment BC is blank. Angle C. Mark the triangle where they're talking about. Line segment BC would be here, and angle C. If I didn't tell you already, we're going to use each word only one time, and we've already used opposite of, and also they're not really opposite of. Instead, they're right next to each other. Well, being right next to each other is not the same as being between, and included is a lot like between, not kind of a synonym for it. So I think the best fit would be adjacent to, because angle C is right here, and that touches or is right next to angle C and line segment BC. Third one, line segment AC blank angle A and angle C, also referred to as an included side. So they're giving us a little bit of a hint here. Line segment AC here and angle A and angle C. Well, how does that relate? How does line segment AC relate to angle A and angle C? We've already used these words here. They used included, and it seems to make sense that line segment AC is between angle A and angle C. Because angle A is here, angle C is here, and line segment AC is in between those, connecting those two angles together. So let's fill that in as well. So what must go in our last blank? Angle A is the angle in line segment AC and line segment AB. So angle A is the blank angle in line segment AC and AB. Well, the only word left is included, is very similar to talking about in between, and here's line segment AC and line segment AB. And when you draw those two line segments, you create angle A. Angle A is the included angle in those two line segments. So this will be some vocabulary that we'll continue to use to talk about parts of a triangle and how they are in relation to one another. Let's end on classifying three types of triangles. In this last section of this video lesson, we are going to be classifying triangles by sides and angles. So I've included three different triangles here. Our first triangle is called a scalene, our second triangle is called isosceles, and our third triangle is called an equilateral. And that has to do with the number of equal sides and equal angles for each of these, and I purposely left a blank. These are words I believe you've learned about triangles before, but let's see if you remember them. Can you remember what goes in each of these blanks? Here's a hint. I've marked up each of the three triangles with matching tick marks or angle marks to indicate which sizes are equal. So examine them all closely and let's see if we agree. So how'd you do? Here we have a scalene triangle as we talked about, and it has no equal sides. That's why we use a different tick mark on each side, and no equal angles. So a different number of angle arc markings. Here I used 1, here I used 2, and here I used 3, showing 3 different angle measurements. On an isosceles triangle, we have 2 equal sides. So right here and here only have 1 tick mark, so they're equal. And this is a different side length, so we use the 2 tick marks. They also have 2 equal angles, so the bottom 2 angles are marked as being equal in measure, whereas with 2 angle arcs, whereas the top angle only has 1 arc, so it's a different angle measurement. And on our equilateral triangle, we marked every side with 1 tick mark to show that all the sides were equal, and we marked each angle with 1 angle arc to show that all the angles were equal in measure. So that's just a little reminder about the types of triangles as we classify them by sides and angles, and learn to use tick and angle marks to denote which measurements are equal. That concludes our video lesson for today. Please come ready to do more problems like this in class.